right, today, so yesterday we talked about arithmetic sequences, and do you remember the main idea for the patterns that we saw yesterday for the sequences? How did they move from point to number to number to number? They had a common difference and they just kept adding, or sometimes it was adding a negative, so subtracting a number. So today we're going to discuss what's called a geometric sequence. And when you have a geometric sequence, it's that you're going to multiply by a common ratio each time. So the way you hop from term to term is that you multiply. Oops, let me turn my sounds off. Multiply by a common ratio. So an example of that would be 2, 4, 8, 16. How are we hopping from point to point to point? We're multiplying each previous one by 2, right? So the common ratio in this sequence would be 2. How about 10, 2 fifths, 2 25ths? Yeah, we're multiplying by 1/5 that time. Which some kids looked at that and went, oh, she's dividing by 5. Well, isn't multiplying by 1/5 the same thing as dividing by 5? So the idea is the common ratio has to be written as a ratio, therefore a fraction. So keep that in mind. All right, the explicit form for a geometric sequence, and I believe this is on your green formula sheet. Is it? Did I lie about that? Is it the second one down? It'd be at the top, kind of like right underneath the arithmetic if it's on there at all. Can I just steal your sheet? Thank you. It is on there? Yeah. Yeah, somewhere there. Oh yeah, third one down, sorry. So the nth term of a geometric sequence. Yep, that guy. So it says it is a sub n, so general term, equals a sub 1, the first term, and then times a common ratio r to the n minus 1 power. Now, I think that formula looks scary to kids because it's got what we know is going to be a fraction, it's got a weird exponent thing. These are actually a lot easier, in my opinion, than arithmetic as far as the math goes, because to solve for these is pretty simple. Just like yesterday, we also saw what was called a recursive formula. So when you have a recursive formula, it's going to start similarly, where they're going to say a sub n minus 1. Who remembers what that meant? The previous term, good. And then they're going to have you take that previous term and multiply it by this r, whatever this common ratio is. So we need to probably write some things down on our notes. This stands for the previous term. R stands for the common ratio. Thank you. Who's it for? He's not here yet, but you want me to hang on to it in case he shows? Yeah. Okay. So if I back up to the explicit formula, whoops, too far. Take a wild guess what a sub 1 stands for. The first term, just like yesterday. And then r is the common ratio. And then if they leave it as a sub n with a variable as a subscript, they're asking you for the general term. So if that's the case, you're going to leave n as a variable up here as well. But if I ask for a very specific term, like the 8th term, in that case you would put an 8 up here in the formula. So you have that same n minus 1 factor into your formula to indicate, like, if you're hopping from point to point, like backwards or forwards, we have to think about how many hops we're going to take to get there. So we'll take a look at some examples here. They want me to first determine if it's geometric or not, and then find the common ratio. If you have a hard time seeing common ratios, there's a pretty easy formula that you can use. As long as you can find 2 consecutive terms, you just have to divide the second one by the first one. So I'm just going to write it as a sub 2 divided by a sub 1. That's one way to find the common ratio. But it could be any consecutive terms, like a sub 10 divided by a sub 9. Just anything where one follows the other. So here, if you're not real sure, you could calculate the common ratio. 8 over negative 16, which reduces to a negative 1/2. So if it makes sense that you're multiplying by negative 1/2 every time, then yes, we have a geometric sequence. Is that one going to work out for this pattern? Is it going to give you an 8 and then a negative 4 and then a 2? And notice how it's alternating signs. That's because the common ratio is negative. So when you have a negative times the negative, it becomes positive, And then when you multiply that positive by another negative, it goes back to negative. So it's going to alternate like that. It's called alternating series or sequence here. So yes, it is geometric, and the common ratio is -1/2. So let's take a look at this one. Do you feel like there's a common ratio? Well, can you tell me how they got from -20 to -10? They multiplied by 1/2. Does that work to get you to -20/3? No. So we saw this yesterday where some of the terms were written in fraction form and some were not. And then we spent a lot of time getting common denominators yesterday, but that's because the arithmetic sequence moved like with adding and subtracting. So common denominators were definitely necessary. What we might want to do here, though, instead of worrying about common denominators, maybe we just want to worry about what this fraction used to be. So if you kind of look at the pattern here up in the numerator and the pattern down in the denominator, do you feel like you can isolate those patterns separately? For instance, 4, 8, 16, what number do you think came before the 4? A 2. And then down in the denominator, 3, 9, 27, what number do you think came before the 3? A 1. Well, guys, 2 over 1 is still a 2, yes? Okay, so just keep in mind that we can always rewrite fractions in non-fractions in fraction form if we are trying to see a pattern. That's going to come up useful in a minute. But anyways, do you see a common ratio? I don't know. Fractions kind of freak me out, man. So maybe I'm not sure. Maybe I'm going to calculate the supposed common ratio by taking the second term, which is 4/3, and then dividing by the first term. But remember, dividing a fraction is multiplying by his reciprocal. So that reduces to a 2/3. Let's see if that works. If you multiply 4/3 by another 2/3, do you get 8 over 9? Yeah, and then same thing here. So yes, we most definitely have that geometric pattern. We calculated, but now I understand why the ratio is 2/3, because you were multiplying all the numerators by 2 and the denominators by 3. All right, same thing here. Let's see if we can find the pattern. I feel like we definitely have a pattern. Can you find the common ratio? And if you're not sure, you're just going to divide the second term by the first term. So we got a -4. Oh, read directions, Abruzzo. What was I supposed to be doing? I wasn't even supposed to be figuring out if it was geometric. It said it is geometric. I forgot to answer the last question. It says, give me the next 3 terms. So continue on our pattern, guys. Multiply the numerator over here by 2 and the denominator by 3. Oh, man. Yeah, grab your calculators. I'm kind of sick of doing this one in my head. (32/81). Oh my gosh, keep going. I got the numerator. 64/243. Cool, cool. 128 thank you. Cool. All right, this one we're multiplying by -4, and that is -26. What is that? -256. Thank you. All right, and then I'm going to kind of give up on mental math. Could you keep multiplying by -4? Positive 1024, and the next one should be something negative. 4096. Awesome. Very good. Okay, moving along. So given an explicit formula, they want you to find the common ratio and then the first 4 terms. So the common ratio is staring at you. Do you see it? Common ratio is the base of this question. There's a little exponential factor going here, and the base is the common ratio. So the common ratio is 6. They want me to find the first 4 terms. I would love it if you guys could get used to using this notation. So a sub 1, a sub 2, a sub 3, and a sub 4. I was just kind of keying through the test, and sometimes instead of a, they switch it and use u instead of a. So that's okay. It doesn't really matter. Your book, I think, tends to use a sub whatever the value is, but some other books and calc books start switching it out for u's. So don't panic if they switch the notation to u. All right, guys, the first term. I think we actually know what the first term is because it's staring at you. It's a 2. But the other thing you could have done if you weren't sure is you could plug in n equals 1. So then here for n equals 2, you can either plug in a 2 for n, or you can just start multiplying by that common ratio, right? So 2 multiplied by my common ratio would be a 12. And then multiply by the common ratio again, is that 72? And then one more time, I'm going to need a little help on that one. Is it 4? Oh, no, I don't have the key. 432. All right, number 9. You're staring at your common ratio. What is it? -4. All right, same idea, first 4 terms. Well, the first term's staring at you, so don't think too hard. It's -0.25. You can change these all to fractions if you don't like the decimal factor, but since they went ahead and introduced a decimal to me, maybe I'd keep everything as a decimal. Me personally, I don't like working with decimals if I have to do mental math, so I'm going to go ahead and call it a -1/4. Now to move forward, you could either plug in the appropriate number for n, or you could just multiply by the common ratio. So -1/4 times -4 would be a +1. Multiplying by a -4 again will be -4. Multiplying by a -4 again will be a 16. All right, so this time, let's talk about recursive formulas, which, as I was kind of walking you through those last 2 questions, we were kind of doing the recursive formula, it just wasn't written in that notation. So remember, a recursive formula says to take the previous term, whatever that is, and then to multiply it. I always put a big gigantic multiplication sign like an asterisk because that just helps my brain. Multiply it by the 1/6. So that right there tells you that your common ratio is the 1/6. That's the thing that's making you hop from term to term to term. So they want me to find the first 4 terms. Well, good news. They have to give me a starting point, a sub 1. So there's the first term. And I don't really think I want to write a formula, because we have a nice enough one right now. Let's just keep multiplying everything by a 1/6. So what's 108 times 1/6? 18, yeah. And then keep going. So 3, the third term is 3. And then the fourth term would be 1/2. So we just kept multiplying that by 1/6 over and over and over again. Oops, I'm not going any further. We good on that one? Okay. So here, they give me the start of a sequence. They say find the common ratio, so that notation right there tells me that we have a geometric sequence. So to find the common ratio, you can either think really hard, or you could use your little formula where you take the second term and divide it by the first term. So 8 divided by -2 is -4. And then it says to find the 8th term. Well, it's up to you guys. You could either just go ahead and write a formula, which would be the first term times your common ratio to the n-1 power, and then what would I do to find the 8th term? I'd put an 8 in all the n's, right? So -2 times -4 to the 8-1 power. That is a very formulaic way to do that question, and there is absolutely nothing wrong with doing that question that way. It's a pretty big number, right? 32768. So I have no issues with you guys using the formulas to get that question right. However, some people are conceptualizers and they don't really like to just follow the formula straight across. In hindsight, once we look at their work, we're going to realize they actually secretly did follow the formula. What a lot of kids will do is they'll say, okay, well, I'm going to start at -2, the first term, and I'm going to multiply by our common ratio of -4. And then how many times are they going to do that if they have to go from the first term all the way out to the 8th term? They're going to do that 7 times. I hate to break it to these kids, but they kind of did the same thing, right? So they were visualizing how the formula works without actually literally plugging things into the formula. So you have to kind of make a decision what kind of a learner you are. And some of you are, it's just based on like how lazy you're feeling at the moment. If you're not feeling very mathematically creative and you just want to use the formula, that's okay. We're all going to use the formula in some fashion. Okay, so this time it says, please find your explicit formula. I think these are the easiest ones because geometric, you don't have any simplifying, ever. So your explicit formula says start with your first term, which is a 2, and then multiply it by the common ratio to the n-1 power. So the only thing you have to really figure out is what your common ratio is. So that's Pretty easy one there, right? 10 over 2 is 5. And there's never any simplifying to do in explicit geometric formulas, so even the computerized answer key will have that exact stuff written down. I would like you guys to put your common ratios in parentheses. You don't have to technically, because it always implies order of operations properly, but I just think for kids to understand how to type it in their calculator later, it helps if you put parentheses. So same idea here. Explicit formula says start with your first term, which is a 3. And then we're going to multiply that by the common ratio to the n minus 1 power. So figure out your common ratio by taking the second term divided by the first term. Well, that's not too bad. So 1/3. So here, they're giving you a recursive formula, and then they want you to figure out the explicit formula. Well, if you think about the explicit formula, all you really need to know is the first term and the common ratio. So I think we know the first term because they're going to flat out tell you the first term. And I think if you look carefully, you're staring at the common ratio. Do you see it? Boom, right there. It says multiply every previous term by 1/2. So I think we're done. The explicit formula is 16 times common ratio, which is 1/2, to the n minus 1 power. Easy peasy lemon squeezy, right? So what started out looking as kind of a weird formula is actually very friendly. So explicit formula here, first term, 2, times the common ratio of, you're staring at them, if you look closely, it's a -5. Definitely you need to have parentheses on that one, please. And then to the n minus 1 power. Beautiful. All right, let's see something more exciting. Well, that's not that much more exciting. All right, same idea. They want you to write a formula, but this time they want a recursive formula. So remember, a recursive formula will start with how you move from the previous term. So it's going to start with a sub n minus 1, and then for geometric, instead of adding things like yesterday, today you're going to be multiplying by the common ratio. So as long as you could figure out your common ratio, you're good. So your common ratio is trace. But you also have to tell your reader where to start your pattern at. So where's your first term, or what is your first term? It also happens to be a 3. Yeah, a little color coding in my notes might make sense. So here, recursive formula says to start with the previous term, whatever it may be, and multiply it by your common ratio. What is your common ratio here? -2. Very good. Now, you don't have to put parentheses here. I think we can all tell what's happening on that formula. But you do need to tell me where to start my sequence. So your sequence starts at 3 again. It's a good number to start with, I guess. I don't know. It's been a lot of 3s here. So this time I'm giving you an explicit, and I want you to write the recursive. So if you stop and think about what did you need to write the recursive formula, well, you need a first term and you need a common ratio. And guys, I think you're staring at both of those things. This is your first term. And this is your common ratio. So the recursive formula says take your previous term and multiply it by the common ratio, which is -5. And then you have to tell your reader where to start. So the first term is 0.4. So I don't know about you, but I think this is a fabulous lesson for a Friday. It's a good one. I think I actually might do my homework tonight, Mrs. Brizo. Thank you. No, Friday's your night for math homework, and I know it. You all spend your Friday nights doing your math homework, don't you? Wait, what? Last night? High five. All right, find the term named in the problem and the explicit formula. So because they want my explicit formula, I might go ahead and just write the explicit formula first. Because then if I'm a formula baby, I can go use my formula to find the 11th term. So the explicit formula, oops, why am I using blue? The explicit formula is a sub 1, so this guy, times the common ratio. Uh-oh, that's going to take some thinking if I'm not careful. Some of you can easily tell what's happening to bounce from term to term as far as going forward. If you're not sure, you can take your second term and divide it by your first term, which means if you're using your calculator, please use parentheses. But I think you're pre-calc and you guys can totally do this without a calculator. 3's cross cancel and 2 4ths reduces to a 1/2. Did you notice that the numerators weren't changing, but the denominators were doubling? So that's why the common ratio was a multiplied by 1/2. And then, of course, to the n minus 1 power. Now, if I want the 11th term, I can go ahead and use this handy formula I just came up with. So the 11th term is 3/2 times 1/2, and then to the 11 minus 1 power, better known as the 10th power, because you're going to have to hop 10 times away from the first term, right? It's, yeah, something, isn't it? What is it? 3/2048? And it'll say on your test that you must write the exact answer. So anytime these common ratio questions come up with funky little fractions, do not write a rounded off decimal down. You're going to get that question wrong if that's what you did. Okay, so math enter that baby. Very good, very good. So far, so good? Oh man, you guys are going to have time to do homework. You won't even have to wait till Friday night to do your homework. Are we okay if I skip 21? Yes. Now that you've promised me homework time, you can skip all the questions you want. All right, so these last few are a little tricky. This is the trickiest it gets, though, so if you can handle this, then you're fine. Okay, they went ahead and gave me the first term. Cool. They gave me the 4th term, and then they want me to find a random term, the 11th term. So, it does say write the explicit formula. So maybe that's kind of my first goal, is to figure out that explicit formula. Good news. They went ahead and gave me one of the parts I need. They said the first term is 3. The thing, though, that they didn't tell me is the common ratio. And it can't be as simple as like, oh, they gave me 2 consecutive terms, because they didn't give me 2 consecutive terms. So think about what's happening here. They gave you the first term, and then there's like 2nd term, 3rd term, and they gave me the 4th term. So this is a 3, and this is a 24. So they multiplied by the common ratio. Yes? Due to weather. Kids are going to be late because of weather. Not even bad weather, just weather. All right. It's not even, I don't know what happened. It is foggy. To be fair, it was very foggy today. Oh, no. Found that one out the hard way, did you? Oh, no. Okay. Yay! All right. So how many times did we multiply by this mysterious common ratio to hop, hop, hop to 24? 3 times, yes. So this is what I would like you to think about. You took I'm going to set up the formula the first time, and then we'll conceptualize it next time. Let's say I have the 24 as my answer to this formula, huh? And I know that I started at a 3, and I don't really know what the common ratio is, but I was told that I hopped 3 times. Now, look at the formula. Where's the 3 coming from? Because we had the 4th term, and we were looking back to the 1st term, or from 1st term forward to 4th term. Either way, that's where the 3 is coming from. Okay, algebra, kick in. How do you solve for this? You divide by 3. So that's an 8. And then the common ratio 3 times. So now mathematically, you're supposed to either take the cube root, or can someone reach very deep into their memory? What power do you raise it to? 1/3. Very good. Undoing the power is as simple as taking the reciprocal power. I want to bring that up to you because we're going to have some funky powers coming up here. So, reciprocal power, please. What is 8 to the 1/3 or the cube root of 8? Yes, 2. Yes. Yes. Why is it not the same? So arithmetic was continual additions. So we found the range between them and then divided them. We've essentially found slope. Did you guys catch on? It was like the same as the slope formula. It was very strange, wasn't it? It's because of the derivation of what the formula looks like. So what we're doing here, James, like on arithmetic, it's as simple as like if you want to know the difference between two numbers that are in a sequence of an arithmetic sequence, you would just subtract them to figure out how far away they are from each other. But in geometric, you would divide them. So basically we're finding like a much larger common ratio than what we are calling the common ratio. But then we have to either take a root or a reciprocal power because we applied that ratio so many times. Okay? Guys, I don't know if you need to set this up every single time. If you guys can start thinking like, oh, well, I need to take the ratio of 24/3 and do whatever root it is to it, that's fine. So this is using the formula. Oh, but we're not done, because what else do they want? The 11th term. So it is kind of up to you how you approach this. We already have the formula, so you might as well just use it if you're feeling a little foggy on a Friday. Ah, fog. All right, so 3 times the common ratio of the 11 minus 1 power, better known as the 10th power. Type. Is it 3072? Cool. All right. So let's take a look at this next one. This one kind of stinks because notice what they didn't give me this time. They did not give me the first term. So on top of everything else I got to figure out, I also got to go back and figure out the first term. But once we have the common ratio, that'll be fine. All right, here's what I want to do. I want to start with the 5th term, which is 4/81. So what I'm using is this general formula, except I'm doing something a little different. I want to compare it to, this is the 2nd term. Now, we generalize this formula here with 1, but technically I don't have to use the first term here. It can be any term, because we're going to incorporate that up into our parentheses here. This is going to be a little tricky, so hang on. What goes up in this parenthesis here is not always n minus 1. In this case, because we use the 2nd term, this would be n minus 2, wouldn't it? And what was your n? Which term did we use here? This was the 5th term, right? So think about this formula, guys. How many times would you be hopping from 2nd to 5th? You would be multiplying 3 times. 3 steps. Right. So if you want to generalize the process here, here's what you're doing. To find the common ratio, I think some of you were like, give me a formula to use. Here you go. You're going to take your, I'm going to call it final term, although it's not the final term. You're going to divide it by the initial term, so whatever your earlier term is. And then you're going to apply a reciprocal power of 1 over the steps, or hops, or whatever you want to call those. Because look at what's going to happen when I go to solve this equation for r. I'm going to divide the negative 4/3 over, and then I would have applied the 1/3 power, or the cube root. So if you would like to use that formula right now, go for it. Although you do have to be careful how you're typing this in your calculator. You're taking 4/81. You're going to divide it by our initial term of negative 4/3, but we don't do that, right? And then, if you're doing this on our calculator, you're going to have to put this fraction in parentheses as well. And then to the 1 over, we decided that was 3 steps. So if you're looking for a way to find steps, I don't know how to notate to this for you guys without confusing you. Basically, you're just subtracting these numbers, if you can figure that out. Subtract the ends, I guess I could write down. What does this come out to? Negative 1 over 27, I think is what I got. Now, if you didn't get negative 1 over 27, okay, 2 things to think about. When you typed 4/81, if you divided by negative 4/3, you have to put negative 4/3 in an additional set of parentheses because it won't divide the fraction properly. The entire this thing has to be raised to the 1/3 power. Are we still not getting that? Did I screw it up? You got it? What? What did I do? Oh, I didn't. I'm looking at the wrong problem. I don't know what I did. Hold on. I never took it to the 1/3 power. Idiot. So cruel to myself, aren't I? Okay, one more time. Negative 1/3. Like I said, we can edit this, right? I still don't know how to edit videos. Okay. Whew, good news. Does this formula help then? I mean, obviously when your ratios are, or your terms are already written as ratios, it gets a little exciting. If they're integers, you could probably muscle through it, but maybe this would be helpful on a nasty question on your homework. Okay, but we're not done because they want the explicit formula. Wah, wah, what do we not have? I don't have the first term. So think about math, guys. If you want the first term and you have the second term, and the second term is negative 4/3, whoops. To move forward in the sequence, you multiply by negative 1/3. How do you move backwards in the sequence? Oh boy, fractions. So you could divide by negative 1/3, but what's the same thing as dividing by negative 1/3? Multiplying by negative 3. So to go backwards in your formula, you actually have to multiply by negative 3. That would be a 4. The first term is 4. Or did I screw that up too? Oh my gosh, I think I did screw that up. I think I have the wrong sign. I'm quit keying things from now on. Alright, so our first term we just found out was a positive 4? Okay, I have negative 4 in my key. I quit. Alright, so our general sequence is 4. Now that I figured out our common ratio, because you guys helped me, it was negative 1/3 to the n minus 1 power. So there's your explicit formula. They want the 12th term. Well, you know what? I'm so sick of thinking. Let's just plug into the formula, guys. If you want the 12th term, plug in a 12. So that would be something. You can just type to the 11th power, obviously. You don't have to do 12 minus 1 power. I obviously don't have the right answer. It's really small, though, isn't it? Yeah. What does your scientific notation say? What's the after the E? So 0.1, 2, 3, 4, and then read me a couple decimals. 2258? And it was negative? Okay, there you go. And when you try to math enter, it doesn't really tell you anything, does it? Okay, so if for some reason you had some evil bear of a teacher, I won't do this to you, and they were like, I will not accept that answer because it's not exact. What you would have to do is apply the 11th power and leave it in like to the 11th power notation. Cool, let's not do that. That was awful, wasn't it? Okay, I believe I promised you some homework time. Let this be it. In your homework, what are we assigning you? Something wonderful, no doubt. Are they circled? God bless that woman. She's so wonderful. All right, so obviously the ones at the end of your homework are going to be like the ones that are at the end of your notes. So maybe that would be a good place to start while you're here with a teacher. I mean, there's no promises that I actually know the right answer. I'll have to figure that out. But I am posting the computer-generated answer key. I think it should be okay. But if someone feels like there's a mistake, sometimes what we do is we adjust the question on the program, but we don't adjust the answer key because we forget. So if you're like dead certain like the computer key is wrong, you might not be wrong. It's okay. All right, good luck, everybody.